Let's discuss the technical design of this feature. What's your opinion on this architecture? I prefer a microservice architecture for this system. A monolithic approach might be simpler at the beginning. We need to consider the scalability of the solution. How can we make this system more maintainable? Let's talk about the pros and cons of each option. This solution is more robust in high concurrency scenarios. We should avoid over-engineering the system. Let's keep the design as simple as possible. How does this module interact with other components? We need to define clear interfaces between services. Let's standardize the API format for all endpoints. We must ensure backward compatibility. Breaking changes should be avoided if possible. Let's document all the interface contracts clearly. What data format should we use for communication? JSON is more readable than XML in most cases. We can use Protobuf for better performance. Let's design a reasonable data structure. How do we handle exceptions in this flow? We need a global exception handling mechanism. All errors should be caught and logged properly. The system should not crash easily. Let's implement a retry mechanism for failed requests. We can add a circuit breaker to prevent cascading failures. How do we ensure data consistency? Distributed transactions are complex here. We can use eventual consistency for this scenario. Let's add validation for all input parameters. Security is a top priority for this module. We need to encrypt sensitive user data. Let's implement proper authentication and authorization. API access must be controlled by tokens. We should prevent common attacks like SQL injection. All user inputs must be sanitized carefully. Let's set proper file permissions for the server. We need to follow the security best practices. How can we protect the system from brute force attacks? Let's perform a security review before release. Let's talk about the performance bottlenecks. The response time is too slow under high load. We need to optimize the database queries. Adding an index can speed up the search significantly. Caching will help reduce the database pressure. We can use Redis for distributed caching. Let's optimize the time complexity of the algorithm. The current implementation has O(n) superscript 2 time complexity. We can improve it to O(n) log n with a better approach. Memory usage is too high in this version. There is a possible memory leak in the service. Let's profile the application to find the issue. Asynchronous processing can improve throughput. We should use non-blocking I/O for this service. Let's design a multi-threaded strategy carefully. Race conditions may cause unexpected behavior. We need to add locks for shared resources. How do we handle concurrent writes correctly? Let's test the system under high concurrency. Load testing is necessary before going live. Let's choose the right technology stack for this project. This framework is mature and has good community support. The library is lightweight and easy to integrate. We should avoid using deprecated libraries. Let's check the license of the open source components. Compatibility issues may appear after version updates. We need to test all dependencies carefully. Let's fix the version numbers to avoid surprises. This tool can improve our development efficiency. We can automate the repetitive tasks with scripts. How do you implement this feature in code? Let me explain the core logic of this function. The function takes 3 parameters and returns a result. We need to handle all edge cases in the code. Let's add comments for complex logic. The code should be self-explanatory and clean. We should follow the coding style consistently. Let's refactor this part to improve readability. Duplicated code should be extracted into utilities. Single responsibility principle makes code maintainable. Let's write unit tests for all core functions. Test coverage should be above 80% for critical modules. We need to test both positive and negative cases. Mock data is necessary for isolated testing. Integration tests verify interactions between components. End-to-end tests ensure the whole system works. Let's automate the testing process. Tests should run automatically in the CI pipeline. Failed tests must be fixed immediately. A good test suite prevents regression bugs. Let's set up a proper logging system. Logs should include enough context for debugging. We can classify logs by different levels. Let's collect all logs in a centralized system. Monitoring alerts help us find issues early. We need to monitor CPU, memory, and disk usage. Request rate and error rate are key metrics. Let's set up dashboards for real-time monitoring. Anomaly detection can warn us of unusual behavior. We should respond quickly to production alerts. Let's design a reliable deployment process. Blue-green deployment reduces downtime risk. Canary release allows us to verify gradually. We need to back up data before deployment. Rollback plan must be ready in case of failure. The CI/CD pipeline should be fully automated. Let's standardize the build and deploy scripts. Environment parity reduces hidden bugs. Configuration should be separated from code. We can use environment variables for settings. Let's analyze the root cause of this problem. The issue comes from incorrect data processing. There is a logical error in the condition judgment. The variable is not initialized as expected. Null values cause unexpected crashes. The API returns an error code we didn't handle. Network latency leads to request timeouts. The database connection pool is exhausted. A third-party service is currently unavailable. The bug only appears under specific conditions. How can we reproduce this issue consistently? Let me walk you through the steps to replicate it. We need more detailed logs to diagnose it. Let me check the latest logs in production. The error message gives us important clues. Let's debug the code step by step locally. Breakpoints help us inspect variable values. The behavior is different from our expectation. Something goes wrong in the asynchronous flow. The state is not updated correctly in real time. I have a possible solution for this problem. My approach is to add validation before processing. We can fix it by changing the execution order. Let's use a more suitable algorithm here. Caching the result can prevent repeated calculations. We can optimize the query to avoid full table scan. Retrying with exponential backoff is a good idea. Let's add a fallback mechanism for failures. Upgrading the library version may fix the bug. We can patch the code temporarily before refactoring. Do you agree with this technical solution? I agree with your design in most parts. That's a reasonable and practical approach. Your point makes perfect sense to me. I support this decision for long-term maintenance. I have a different opinion on this detail. I'm concerned about the performance impact. This solution may introduce new problems. Let's evaluate the risks before implementation. We need to balance development speed and quality. Let me clarify the requirement again. Do I understand the requirement correctly? The user expects the system to respond in 1 second. We need to support at least 1,000 concurrent users. The function must be available 99.9% of the time. Let's translate requirements into technical indicators. Non-functional requirements are equally important. We should clarify ambiguous points early. Let's confirm the scope before starting development. Unclear requirements lead to wrong implementations. Let's split the task into smaller subtasks. We can work in parallel to improve efficiency. Let's define clear responsibilities for each member. I'm responsible for the back-end API development. You can focus on the front-end interaction logic. Let's coordinate the interface definition first. We need to align the schedule with other teams. Let's set realistic deadlines for each milestone. I need some help with this difficult problem. Let's pair program to solve this together. Let's review each other's code before merging. Code review helps improve code quality. Please check my pull request when you're free. I left some comments on your code. This variable name is not descriptive enough. We can simplify this logic a lot. Let's handle the exception in a better way. The code can be more readable with small changes. Good code review prevents many bugs. We learn from each other during reviews. Technical debt will slow us down later. We should refactor regularly to reduce debt. Let's schedule time for architecture improvement. Good documentation reduces communication cost. We need to update documents when code changes. Let's share knowledge regularly in the team. Continuous learning keeps our skills up to date. We should adopt better tools and workflows. Team collaboration is the key to success. Clear communication avoids many misunderstandings. Let's summarize the technical decisions we made. We've chosen the third solution as the final plan. Let's record the reasons for each decision. The next step is to implement the prototype. We will test and adjust the design iteratively. Let's meet again to review the progress. Any other questions about the technical details? Thanks for your valuable suggestions. This discussion helps us make a better choice. Let's start implementing the plan right away. Thank you for watching. Follow me for more practical videos.